All right, guys, let's jump in. This is Wednesday's video for some more practice with solving equations. We've looked at 1 steps and 2 steps, and I want to make sure we continue to have a solid understanding of this stuff. So we're going to do a little more practice, looking at some special cases and kind of common mistakes I see kids make with these. Let's dive in. All right. A lot of kids have been asking, and I think a little confused this week, about when we change the sign of the negative. So let's look at that right now. On this first problem on the left, notice if we wonder what that operation is, that's the question I've been asking you guys in our practice time. We need to notice that negative 6x is showing multiplication. That is a multiply operation between negative 6 and x. But if we look over at the other side, over here, negative 6 plus x, we have to notice that's a different thing going on. When we ask ourselves about that operation, we have to see that it's addition. Okay? And you know what? I'm going to say addition or subtraction. It's not important which way you see that, as long as you understand it's an add or subtract operation there. Okay, let's go back to this left-hand problem. When we solve that, because it's multiply, that's going to tell me I need to divide. I'm going to use the fraction bar for division. And what I'm going to divide off is everything in front of x. So whatever's here is what needs to go. So I'm going to divide off the negative and the 6. When I divide 6 by 6, they cancel. And when I divide a negative by a negative, they cancel. Leaving the x by itself. Do the same on both sides. And we end up here. Let's look at the other side and see how that's different. On the other side, because it's an addition or subtraction, the important thing to notice is we can think of this problem as a good guys, bad guys type of situation, which means we are going to cancel off some values added to x. Whether it's some bad guys added with x or good guys added with x, there's a group of something added to x on the scale. That's different than a multiply divide problem, when there's a multiple of x or something dividing with x. If it's bad guys, good guys, then we need to notice what the sign is. Are we adding some bad guys or adding some good guys? And whatever it is, we need to bring the opposite. In this problem, it's adding in some bad guys, so we bring good guys. That's what's going to cancel it. Okay. Notice, please watch this yourself. If you want to do well on the quiz, I can guarantee there'll be one of these problems Friday. If we end up doing something like this, okay, and I see kids do this while they're learning, you need to recognize that's not going to cancel. Negative 6 and negative 6 is bad guys, more bad guys, bigger group of bad guys. You're going to end up with this as the next level of your equation, and we didn't get x by itself. Okay, we just added more to the scale. So watch for that and ask yourself, what am I going to cancel that negative 6 with? It's a positive 6. Now those cancel away, leaving the x by himself and doing the same on both sides. We end up with that. So what we want to notice is this here. On the first problem, we keep the signs the same because it's a multiply or divide style of problem. And whatever the multiplying or dividing value with x is, it gets canceled off with its sign. Over on the right, if it's an add or subtract style problem, we do flip the sign when we cancel because we see this as good guys or bad guys. And so the flipping of the sign is the operation that we have to flip in order to cancel the number. Okay? So if we were just real quick, well, if I can move the dang screen. There we go. If I was to just throw up 2 more problems like this, and that same problem, just different operations, but I use the same values to make you kind of really consider what we're going to do here. We need to look at the first one on the left. And again, because that's a divide, we know we're going to multiply. And in a multiply or divide problem, everything connected with x has to be multiplied or divided off, so we do include the negative. The 4's and negatives cancel, and that leaves the x by itself, and we do the same on both sides. On the right-hand problem, x minus 4, this is an add or subtract. That tells us it's a good guy or bad guy scenario. A minus 4 tells us we need to bring a plus 4. Okay, and I could even, since that was what we just did a minute ago, if I switch this around, it really doesn't matter. If this is an x plus 4, we're still seeing it as good guys, bad guys, which tells us a positive 4, I need to bring a negative 4. I see good guys, I need to bring bad guys. They're going to cancel each other to leave the x by itself, which in a sense is like flipping the sign, but I think it's easier to understand. Think of good guys, bad guys. If it's an add subtract, if it's a multiply or divide, the sign goes with it. Okay? You guys can try right here. Why don't you try this to make sure you get this? And I might flip the side, the sides of the page the problems are on, so watch. Let's see, what do I want to put where? Oh, that's on the wrong side. There you go. Solve those two. I'll give you a minute. Go. All right, you should have paused me and you should have finished. On the left, that's a multiplication connecting them. I need to use divide to cancel. And on a multiply divide, everything has to cancel off, including the signs, to get the p by itself. So we should have been doing this and got positive 3. However, on the right-hand side, we should see that it's good guy, bad guy. So the sign is flipped here because we're bringing good guys to cancel the bad guys. And we end up now with m equaling -1. There you go. All right, moving on. Okay, this is just an example of some stuff that was on your homework. I think I neglected to put one of these in the two-step examples video yesterday, so we'll just walk through that. We always want to cancel what's farther away from the variable, or another way to say that is opposite of the order of operations. So add, subtract terms would be canceled first. And in that case, that's going to be the -4. He's going to go first, so we're going to cancel him off. And again, that is for bad guys. Ignore the -7. We could look at this problem as if there wasn't even a dividing -7. You could just look at it as m minus 4. It's an add, subtract. Those are bad guys, so I'm going to bring good guys to solve. Don't even worry about this dividing -7 until you get to that part. So I'm going to add 4 to cancel it. And I'm going to do the same on both sides. I'm going to bring down everything that's still on the left, so the m dividing by the negative, or being divided by the -7, and the 16. At this point, it's just a normal two-step, or excuse me, one step. So at this point, that -7 that's dividing, I need to multiply to solve. Remember, don't see it as a fraction, just see it as division. The -7's cancel, leaving the m by itself. The two negatives cancel. Same on both sides, and we're going to get something like, honestly, I got to write that out to make sure I did it correct. Okay, there you go. There's an example of a two-step that's got that dividing value with the variable. Okay, let's do a little word problem action to kind of show you guys how that works. It's often got a certain look to it with two steps. So let's examine this real quick. Okay, carpet world will not be undersold. Get 18 square yards installed for $305.89. That includes the installation charge. So, first thing, they gave us the total. It's $305.89. So let's write that down. Now, two steps often have this formulaic look to them, and there's going to be two pieces. There's always going to be a single flat fee that's included right here. It's the $54 installation charge. There's just one of those. This is often how a two-step goes. They'll have a one-time fee, a one-time cost, and then they will also have a multiple units of something cost, which is right here. 18 square yards of carpet. Okay, so you've got 18 square yards of carpet, and you've also got a flat fee of a $54 installation. So what we end up with, and this is a very common thing in a two-step again, is try that again, is there's my flat fee of $54. I'm going to add $54 to the per yard cost to get the 305. So the total has got an installation plus some carpet, and it's 18 yards of carpet times some unknown amount. We are trying to figure out what this place charges per yard for their carpet, and that's where that would go. So this problem now is telling us 18 yards at some cost per yard. Maybe it's $5 a yard. We would multiply that by 18. Then it's $54, a single one-time fee that we add on. And when we put those together, we get to the 305.89. And if you look at it, oh, this is just a two-step. We've been solving these over and over. The numbers are just a little bit bigger. So let's solve it and see how simple it is. Take on the add subtract value first to cancel that. That's a plus 54, so I'll do a minus 54. That cancels away. Do minus 54 here. Remember, it's money, so even if you don't see the 0, 0, it's just there. Now we'll bring down the 18x and do that subtraction. So 89 minus 0, that's still just 89. 5 minus 4 is 1, and this last 30 minus 5, 25. Okay, so we got rid of the single one-time cost. All that's remaining is the cost per yard. And again, now we're just going to divide off that 18. So we've got the cost here of $251. That's what it costs for all 18. If we divide that, we're going to see what it costs for each single yard. And that, I'm going to go to a calculator for, because I don't have time for this. Okay, now I have 13.9938888, blah, blah, blah. Round whenever you get a value like that. Generally speaking, 2 decimals is all you need, and when you're using money, that's exactly what you need. So $13.99 per yard, which sounds just like something at a store, right? They always list things at 99 cents. So there we go. It's about $14 per yard. That's how you solve those. You will have one on your homework tonight that's like that. I picked one out, so apply this to that. All right, last thing. Negative variables. I covered this at the beginning of the two-step lesson on a one-step equation. Just coming back to make sure on a two-step it's still clear to you guys. Here's what I'm talking about. All right, let's dive in. Negative 8 minus x. How are we going to cancel that negative 8? What operation is it? It's an add subtract. So we know it's like good guys, bad guys, and we need to bring a plus 8 to that minus 8. The reason it's plus is this sign connected to the 8, not this sign connected to the x. The negative in front of the x applies to the x itself, and we'll have to deal with that at the end of the problem. Right now we're dealing with just this negative 8 here and canceling it. Okay? Those cancel, and you add 8 to both sides. Negative 14 and 8 is negative 6. And here's what I've seen about 1,000,001 times as a teacher. I see this, and student feels like they're done because they got x by itself, But do you see what's missing? What got dropped? And hopefully you said, yeah, Mr. O, you just pointed it out. That negative is still on the x. We didn't solve for x, we solved for negative x. That means we're not actually done. We've got one more step. And you apply what we just talked about yesterday on the video. If negative x is negative 6, positive x is positive 6, and this is the solution, this you will lose some points for on the quiz. You've got to finish and solve every problem for the positive variable, okay? So again, if you see this here, an equation starting with a negative variable, go ahead and solve it just like you always would, but notice that negative is going to come through. It stays on the variable until you deal with it. And then at the end of the equation, once you've solved, just flip the sign. Flip to the positive version of x, and whatever the sign of your answer is, just flip to its reverse or opposite, and you're good to go. All right, peace out, guys. Have a good day.